Scientists have discovered about a dozen exoplanets that sit in the habitable zones of their host stars, and we're going to examine two of them today, Kepler-69c and Gliese 667. Kepler-69c is a fascinating planet that has caught the attention of astronomers. It's located about 2,700 light-years away from Earth. Scientists have given it the nickname Super-Earth or Super-Venus, but whether or not it's habitable is still up for debate. What initially intrigued the researchers was that Kepler-69c orbits a star similar to our Sun, just like Earth does. When Kepler-69c was first discovered, it became a big deal because it seemed to be the most Earth-like exoplanet found so far. However, scientists have been discussing whether it's more like Venus or Earth. NASA pointed out a significant similarity between Kepler-69c's orbit, which takes about 240 days, and Venus's revolution around our Sun. Kepler-69c gracefully circles its host star from approximately 69 million kilometers distance, which is about 0.64 astronomical units AU. It's bigger and heavier than Earth, with a mass of more than twice that of our planet and a radius almost 2 times bigger. At first, there was hope that this exoplanet could support life, but further research dashed those hopes. It turns out that Kepler-69c is located beyond the zone where it is still habitable, closer to Venus than Earth. The temperatures there are extreme and also harsh conditions, making it impossible for any form of life to exist. So unfortunately, Kepler-69c may not be so habitable. When scientists first found this exoplanet, they had some exciting ideas. They speculated that there might be water or an entire ocean on its surface. One researcher even joked about the possibility of intelligent dolphins living there, given the potential for liquid water. NASA officially announced the discovery of Kepler-69c in 2013 during the data release from the Kepler spacecraft. They used transit method to detect this exoplanet, which involves measuring the decrease in brightness when a planet passes directly over its host star. Kepler-69c orbits a star called Kepler-69, and this host star has two other planets orbiting it, Kepler-62e and Kepler-62f. Kepler-69's mass is about 0.8 times more than that of our Sun. Its radius is about 0.9 times the Sun's radius, and a surface temperature of approximately 5,600 Kelvin. It's estimated to be around 10 billion years old and close to the end of its lifespan. Kepler-69 isn't very bright. It has an apparent magnitude of 13.7, so it cannot be viewed without a telescope from Earth. Kepler-69c didn't just get the attention alone. The two other stars orbiting its host star also got lots of attention in the media because they're sited in the habitable zone of their host star. This zone is where the conditions might be just right to support liquid water on a planet's surface. Kepler-69c's similarity in temperature and magnitude to our planet is why it became a top candidate for the possibility of hosting alien life. The amount of sunlight reaching Kepler-69c is subject to fluctuation in the characteristics of its star, which means there are wider ranges of possible values. If there's any water on Kepler-69c, then it is highly likely to find thick clouds. It's hard to imagine a planet covered in a really hot, high-pressure ocean of water, but hey, you never know. However, no matter what, if we want a planet that's even remotely like Earth, we'd need to cool it down globally and reduce the pressure in its atmosphere. One idea to tackle this challenge is to put up massive solar shades in space to help control the planet's temperature. We could also use bright clouds and certain gases to keep the planet's surface nice and comfortable. Now, here's something to keep in mind. The gravity on this planet would be a lot stronger than on Earth, so only specially engineered living things and robots will be able to handle those intense conditions. But think about it. With the way technology is advancing, and by the time we can travel to other star systems, we might just have the tools and know how to deal with this situation. Gliese 667. The exoplanet known as Gliese 667cc, or GJ667cc for short, has been hailed as the most similar celestial object to Earth that we've discovered beyond the Milky Way. The Gliese 667 orbits a unique star that astrophysicists are closely studying. Interestingly, GJ667cc has more resemblance to our planet than Kepler-69c, which was recently verified as a possibly habitable exoplanet. What's neat is that GJ667cc is only 22 light-years away, which may sound far, but in cosmic terms it's quite close. So it's right here in our galactic neighborhood, and has a strong chance of being a suitable place for life. It's amazing to think that not too long ago, just a couple of decades before scientists discovered that exoplanets exist, we could only imagine that these kinds of celestial bodies existed. Now we've confirmed the existence of over 700 exoplanets, and have around 1,500 more candidates waiting to be verified. Kepler 22b orbits a star that looks a lot like our Sun, while GJ667cc circles a red star known as an M-type spectral star. These M dwarfs are colder and have a compact size compared to our Sun, and they make up about 60% of all the stars we know about. Scientists and astrophysicists are conducting extensive research on these M dwarfs. It's interesting to note that most exoplanet-hosting stars are mostly one of these M dwarfs, and that adds to the intrigue surrounding GJ667cc. The habitable zone of a star is the range of distances where a planet's surface temperatures could support the existence of liquid water, which is considered crucial for life as we know it. The habitable zone where our Earth resides in stretches for about 1 AU, which is the distance between the Earth and the Sun. However, due to the reduced energy that the GJ667cc's host star emits, its habitable zone is much closer to the star. If Earth were in orbit around this star instead of the Sun, it would become an icy world. Luckily, GJ667cc sits at a comfortable distance of about 0.120 AU from its star, which is 8 times closer than the Earth's distance from the Sun. The radiation that GJ667cc receives from its host star is almost 90% of the radiation that Earth gets from our Sun. Although a significant portion of this radiation falls in the infrared spectrum, it's highly likely to be enough for water bodies to exist on the planet's surface. If GJ667cc has an atmosphere similar to Earth's, the temperature will be above 30 degrees Celsius, but a thicker atmosphere would increase the temperatures, creating conditions more like those on Venus, which wouldn't be suitable to host humans. It will also be necessary to figure out if GJ667cc indeed has oceans and the right conditions for life to thrive. GJ667cc completes one orbit in just 28 days because of its proximity to its host star. This means that a year on GJ667cc is equivalent to only 28 days on Earth. This interesting fact suggests that if someone lived on GJ667cc, they could celebrate their 1000th birthday, which would only be less than 100 years here on Earth. However, the length of the days on this planet might be very different. It is likely that because of GJ667cc's proximity to its star, it is locked tidally, similar to our Moon, with one side always facing the star. As a result, one hemisphere would experience a perpetual day bathed in the intense light of the nearby star, while the other side would be in eternal darkness. These extreme temperature differences between the two hemispheres could significantly impact the planet's overall climate. The close distance between GJ667cc and its star means that the star appears much larger in the planet's sky compared to how small the Earth's Sun is from Earth. The host star would look like a red disk, be about 3 times wider than the Sun, and cover an area about 10 times larger. Its faint red light will gently radiate from the planet's surface. There are 2 other stars in the same star system with the GJ667cc, the Gliese 667a and b, located about 230 astronomical units AU away. The distance is more than 5 times the distance between Neptune and the Sun, and much farther than the star system containing Gliese 667c. However, Gliese 667a and b would still be noticeable features in the sky of GJ667cc. Although, there is a major concern associated with the GJ667cc's host star. The GJ667c is the family of dwarf stars known for producing very powerful flares of radiation and highly excited particles, and these flares from M-dwarfs can be over 1,000 times more powerful than those from our Sun. They can also increase the star's brightness significantly within just a few seconds. For this planet to be able to host life on its surface, it will be highly necessary for scientists to resolve this issue, especially considering the planet's proximity to its host star. Another challenge comes from the strong magnetic field of the GJ667c. Red dwarf stars like GJ667c's host star often have star spots similar to sunspots, which can decrease the star's energy output by about 40 to 45% for several months. Also, red dwarf stars emit very little ultraviolet light. These fluctuations in brightness could potentially hinder the development of human life that we understand. Life on GJ667cc would offer a completely different experience than what we are used to on Earth. Scientists estimate that GJ667cc has a minimum mass of at least 4 times more than that of Earth, making it a bit larger and more massive than our planet. However, we still don't know its exact density or weight, so GJ667cc might be a gas planet unsuitable for supporting life. For the development of life, a small-sized rocky or oceanic planet that has its radius ranging from about 1.5 to 2.0 times that of Earth would be ideal. Also, a planet with a higher mass can hold on to a more substantial atmosphere. As a result, the surface atmospheric pressure of GJ667cc will likely be higher than Earth's. If the planet's atmosphere is similar to Earth's atmosphere, then the atmospheric pressure will be higher by a bit. However, in an extreme scenario like Venus's atmosphere, it will be more than 100 times greater, similar to the pressure at the ocean's depths. And that brings us to the end of this video. If you like this video, click on the screen to watch other videos like this one. Don't forget to like, subscribe, and click on the notification bell to get notified when we post a new video.